This is Goliath the crow. Don't get too attached. Today, this 1 centimeter crustacean will share the same fate as 40 million of his closest friends, alive sentient in the belly of the largest blue whale in the world. Let's call her Leviathan. Leviathan weighs something like 150 metric tons, and she's the largest animal in the world. But she's not even close to being the largest organism by weight, which is estimated to equal about 40 leviathans. So, where is this behemoth? Here in Utah. Sorry, that's too close. Here, this is Bando, whose name means eye spread out. Bando, a quaking aspen, has roughly 40 million genetically identical cultures. Those all grow from one enormous root system, which is why scientists consider Bando a single organism. Bando is the clear winner of the world's largest organism by weight, an incredible 6 million kilograms. So how did Bando get to be so huge? Bando is not an unusual aspen from a genetic standpoint. Rather, Bando's size boils down to three main factors: its age, its location, and aspen's remarkable evolutionary adaptation of cell cloning.
So first, Bando is incredibly expensive because it's incredibly old. How old exactly? No one knows. Dendrochronologists estimate range from 80,000 to 1 million years. The problem is, there's no simple way to gauge Bando age. Counting the rings of synchrotron will only account for up to 200 years or so, as Bando is in a constant cycle of growth, death, and renewal. On average, each individual trees live 130 years before falling and being replaced by new ones. Second, location. During the last ice age, which ended about 12,000 years ago, glaciers covered much of the North American climate, friendly to aspens. So, if there were other comparatively sized colonies, they may have perished then. Meanwhile, Bando's corner of Utah remains glacier-free. The soil there is rich and in nutrients that Bando's continually replenishes as it drops leaves and chunks. The nutrients return to nourish the new generation of clones, which brings a two-thirds cause of Bando's cloning. Aspens are capable of both sexual reproduction, which produces a new organism, and asexual reproduction, which creates a clone. They tend to reproduce sexually when conditions are unfavorable.
And the best strategy for survival is to move elsewhere. Trees aren't particularly mobile, but the seas are. Like the rest of us, sexual reproduction is how Bando came into the world in the first place, all those tens or hundreds of thousands of years ago. A pollinator carried pollen from the flower of one of his parents to the other, where a sperm cell fertilized an egg. That flower produced fruit, which splits open, releasing hundreds of tiny light seeds. The wind carried one to west part of land in what is now Utah, where it took root and germinated into Bando's first stem. A couple of years later, Bando grew mature enough to reproduce asexually. Asexual reproduction, or cloning, tends to happen when the environment is favorable to growth. Aspens have long roots that burrow through the soil. These can sprout shoots that grow up into new trunks, and while Bando grew and spread out, so did our ancestors. As hunter-gatherers who made cave paintings, survived an ice age, found their way to North America, built civilizations in Egypt and Mesopotamia, fought wars, domesticated animals, fought wars, formed nations, built machines, and invented the internet, and always new ways to fight wars.
Bando has survived many millennia of changing climate and encroaching ice, but it may not survive Earth. New stems are growing to maturity much more slowly than they need to. In order to replace the trunk that formed, scientists have identified two main reasons for this. The first is that we've deprived Bando of fire. When the fire cleared a patch of forest, aspen roots survived, and sent shoots bursting up out of the ground by the tens of thousands. And secondly, grazers like herds of cattle and mule deer, whose natural predator we've hunted to the point of local elimination, are eating pendle fresh growth. If we lose the world's largest organism, we'll lose a scientific treasure trove. Because pendle trunks are genetically identical, they can serve as control settings for study on everything from the tree microbiome to the influence of climate on tree growth rate. The good news is we have a chance to save pendle by reducing livestock grazing in the area and further protecting the vulnerable young saplings, and the time to act is today. Because as with so many other marvels of the natural world, once they are gone, it will be a very, very long time before they return.